before going to explain the electromagnetic waves, let's see the terms present in the Maxwell equations. The first term is the H bar and V bar, J bar, rho. Basically, these are the four terms present in the Maxwell equation. The first term is the magnetic field, and second term is the electric field, and third term is the current conduction density, Second one is the volume charge distribution. Okay. So, what is the source of the electric and magnetic fields? Basically, we have the two types of the magnetic fields. First one is the static magnetic field. Second one is the time varying electromagnetic field. The source of static magnetic field is the steady current. That is the source is the steady current. That is nothing but a DC current. And the source of the time varying magnetic field is the AC current. Time varying magnetic field means it consisting of both time varying electric and magnetic fields. It is nothing but the electromagnetic field. And the source of the electric field is charge. If I want to obtain the static electric field, the source is the charge at rest. So the terms, there is two terms representing the sources of the magnetic field and the electric field. Next. Coming to the terms on the left side of the Maxwell equations, here we have del cross H bar, del cross E bar, del dot B bar and the del dot D bar. Here all these four terms representing the how electric and magnetic field is varying with respect to space. We already know signal or field, anything is function of time and space. On the left side of the Maxwell equations, we have fields, how the fields are varying with respect to space. On the right side, we have the how fields are varying with respect to time. Let's see. This del cross H bar is nothing but the net value of Ax, Ay, Aj, dou by dou x, dou by dou y, dou by dou z, Hx, Hy, and Hj. If I solve this equation, I will get how the components of H bar, that is Hx, Hy, and Hz. All these components vary with respect to XYZ axis, right? So if I expand these equations, the components Hx, Hy, and Hz, how these are varying with respect to x and y and z. Similarly, del cross E bar, it will give the how the components of E bar is varying with respect to XYZ axis. These two are nothing but the curl of the electric field and the magnetic field. And the below two equations are representing the divergence of the electric and magnetic fields. And these two also represents the same similar equations. How electric field is varying with respect to space and how magnetic field is varying with respect to space. So finally, the left hand side terms of the Maxwell equations are representing the field variation with respect to space. Coming to the right side of the Maxwell equations, here we have the sources of those fields. That is, the first one is the J bar. It is the conduction current density. It requires medium. It is nothing but the flow of electrons. And second term is the displacement current density. It doesn't require any medium. It can be passed through a free space or dielectric also. This type of current is generally seen in the capacitors. And this is we can see it in the conductors. Okay. So the first Maxwell equation is the Ampere's law, which indicate if we have the conduction current density or displacement current density, we can generate the H bar in the space. And second equation is the Faraday's law. Here it indicates the dou H by dou t is the time varying H bar will generate E bar in the free space. That is the second equation. And third equation is magnetic monopoles doesn't exist. That is, this is the divergence. If I consider a surface area, suppose it is the north and south poles. These are the magnetic flux lines. If I take a closer surface area like this, the flux passing through this closed surface area is equal to 0 only if magnetic is not equal to 0, only if the magnetic monopole does exist. That is, if I consider like this surface area, we have the electric flux lines passing through this one, but here we cannot take only north pole, right? For if I cut the magnet, for each piece it will have north and south poles. That is, if I cut the magnet, for every piece it will have north and south poles. So if I want to enclose this magnet in a closed surface area consisting of both north and south poles. So overall, the magnetic flux lines passing through this area surface area is equal to 0. That is the expression for the third equation. Next, last one is the Gauss law. It is unlike the magnetic field, electric field for the electric field, electric mono charges will exist. That is, we can have the either only positive charge, or we can have only negative charge like this. So if I enclose this charge, with a surface area, the flux passing through this surface area is equal to the charge enclosed by that area. That is the expression for the fourth equations. Now coming to the first two equations, the first two equations are very important because these two equations used to explain the radiation mechanism. Suppose these are the four Maxwell equations for the time varying fields, right? Similarly, I can write the Maxwell equations for the static fields also. That is, we have to substitute simply dou E by dou T equal 0 and the dou H by dou T equal 0. So the equations will become del cross H bar equal to sigma into E bar, del cross E bar equal to 0, del dot B bar equal to 0 and del dot D bar equal to sigma. These are the Maxwell equations for the static fields. Suppose if I take a current carrying conductor, the current passing through this conductor is the DC current. So it will generally produce a magnetic field, and the direction of the magnetic field can be obtained by using a right hand thumb rule. That is, if I hold the conductor like this, that is, the thumb indicates the direction of the current, then the direction in which the fingers curl indicate the magnetic force. So this is the direction of the magnetic field. That means because of the current, it is generating H bar in the free space. So del cross H bar equal to J bar. Now previously I mentioned that IDC generates only the static magnetic field, that is dou H by dou T is equal to 0, right? So it will not generate any electric field. So I will come to the time varying fields. Suppose if the same conductor is carrying IAC, again according to the right hand thumb rule, it will generate the magnetic field, that is del cross H bar equal to J bar. But here the current is the AC current, so generally it will produce the time varying magnetic field. That is, here dou H by dou T is not equal to 0. If I have the dou H by dou T, from the according to the Faraday law, it will generate electric field. And what is the direction of the electric field? We already know the direction of propagation, electric field and magnetic field. These three components are mutually orthogonal. So it will generate electric field orthogonal to this element. So the source of this magnetic field is, source of this electric field is minus mu dou H by dou T. And the negative sign indicates it will generate the electric field generated will oppose the magnetic field. And here again the electric field is a time varying one. Dou E by dou T is not equal to 0. And from the first equation, in this case, this J bar is equal to 0 because here we have only the free space. So again it will generate a magnetic field, and this magnetic field is generated due to the displacement current density instead of the conduction current density. Right? Again this H bar is time varying. So it will again generate electric field, and then we can get a magnetic field. Like this, the radiation or electromagnetic wave properties.